This is Algebra 2's Lesson 5.2, Solving Quadratic Equations by Factoring. This is something that some people get to in Algebra 1 way at the end. Some people don't. In my classes, I got to it, but we touched on it very, very briefly. Two goals: finding quadratic expressions and solving quadratics by factoring, and then finding zeros. That's the easy part, finding the zeros. Handful of definitions first. The first one is a binomial. What's that prefix bi means? That means two terms. So x plus 1, that's two terms. 3xy squared is not a binomial, nor is it a trinomial. That is only one term because it's not adding or subtracting to anything. That's a monomial, which we'll look at in just a second. A trinomial, again, the prefix tri means three. 1, 2, 3 things. Again, notice they're adding to each other or subtracting from each other. That's what separates the terms. Binomial 2, trinomial 3. Factoring is a process used to write a polynomial as a product of other polynomials having equal or lesser degree. A degree of a polynomial, x squared plus 2x plus 3. The degree of this polynomial is the largest exponent. So you would say that this polynomial is written to the second degree. When you factor this out, you're going to factor it as something that has x times x. Notice these are only written to the first degree, each of these. That's what it means by a lesser degree. A monomial, mono means single. So an expression with one term. Notice it says 3x. Like I showed you a second ago, it could be something as ridiculous as negative 4,500 x squared y to the third z to the fourth power. That is a monomial. Even though there's a whole bunch of things right there, there's nothing adding or subtracting with that. So that is one term. And then a quadratic equation in one variable is an equation that can be written in the form, and this is your standard form from the other day, from last week, ax squared plus bx plus c, where it's equal to 0, when a cannot be equal to 0. The zero of a function, the number k is a zero of a function if f of k is equal to 0. We'll talk about what that means in a second. Just copy this part right here down. F of k equals 0. Here's example number 1. Factoring a trinomial in the form x squared plus bx plus c. This is the easiest form to factor out because there's no coefficient in front of x squared, which means it's 1. Okay, so you don't have to fool with that one. With the ones we're going to look at on example 2, you have to do a little trial and error work right there in order to figure it out. But all you have to do for this is the shortcut. You take c's value right here, 14. You don't have to look at it as positive or negative. Notice I didn't box it as positive 14. Just factor the number 14. That means 1 times 14 and 2 times 7. An easier way for some people to write it is just like this. 1 times 14 and 2 times 7. Those are the two pairs of numbers that when you multiply them, you get the number 14. Then compare those two pairs to b's value. Again, don't look at b as if it's positive or negative right now. Just look at it as the number 9. When you put these two numbers together, this pair, 1 and 14, you're either going to get the number 13 or you're going to get the number 15. And it's either going to be positive or negative, but none of those are the number 9. When you put these two numbers together, 2 and 7, you're going to either get the number 5 or you're going to get the number 9. Again, it could be any combination of positive or negative, but we'll get the value 9 that we were trying to get, 2 and 7. So we have to use the numbers 2 and 7. So in order to factor this out, the easiest way to do it is to write yourself 2 sets of parentheses, make it say x times x, that gives you x squared, and then put in the terms 2 and, put in the numbers 2 and 7. So notice I didn't put any pluses or minuses yet. Once you have that done, look back at your equation and look at the sign that is in front of C. It's plus. All that means, since it's plus, is they're going to be the same sign. If it was negative, it would be telling you that they're different signs. So that means same. This one, the sign in front of B, tells you since they're both the same, they're both going to be that sign negative. So x minus 2 and x minus 7. So notice about all of this, when you plug in each of these numbers, where m's value, they give you 1, then negative 1, then 2 and negative 2. It's just plugging in all of those values to as ordered pairs. When you sum them, though, when you put them together, m and n's values, 1 and 14, this is what I was talking about earlier with looking at it as both positive and negative. This is the positive value 15. This is the negative value negative 15, positive value 9, negative value negative 9. But again, this is a shorter method for most people to do it this way. Therefore, the table shows that negative 2 and negative 7 give you positive 9. I'm sorry, give you negative 9, which was B's sign was negative. So instead of making an entire table for all of that, try this one right here and do the same thing I just did. Take about 30 seconds and see if you can factor it real quick. Again, this is something that you've got to get good at doing this. This says ax squared plus bx plus c. Factor out the number that is c. And again, don't think of it in terms of positive and negative right now. You know that your b value is 2, so you're going to look for numbers that are close to each other. Like the numbers 1 and 48 are not close to each other. You can use the numbers 2 and 24. Again, they're not close to each other because we're trying to get to the number 2. 3 and 16 does it. 4 and 12 does it. Again, we're getting closer, but we're still not getting to the number 2. Just keep going. 6 and 8 are the only two factors that are going to get you to the number B, which is 2. What I mean by that, when you pair these two numbers, you're either going to get 47 or 49. Again, don't think of positives and negatives. You're either going to get 22 or 26. Again, you're either going to get 13 or 19. You're either going to get 8 or 16. So we're trying to get to the number 2. This is the only pair, 6 and 8, that's going to get you to the number 2. So when you factor this out, you write 2 sets of parentheses just like that. You make x times x, and then you use the numbers 6 and 8. And again, notice I didn't put a plus or a minus yet. The sign in front of C either tells you that they're going to be the same or they're going to be different. A minus means they're going to be different. Okay, now this is opposite the one we just looked at. This one says they're different. Since they're different, this sign tells you that the bigger number is negative. 8 is bigger than 6, so it's going to be negative. They're different. This one has to be positive. That's it factored out. X plus 6 times x minus 8. Okay, this form of a trinomial is not as easy since there is a value in front of a. We will not work with very, very hard, difficult numbers in this position because all it is tedious. It's not really showing your ability when you work in this. It's just a tedious work through it problem. So we will have a couple just to where we can get used to it, but this will not be our focus in here, but we will have a couple of them. 2x squared plus 13x plus 6, okay, where it says kx plus m times lx plus n, where k and l are factors of 2 and m and n are positive factors of 6. Check the possible factorizations by multiplying 2x times 3, and then this is just FOIL. Remember what FOIL is. FOIL means first, then O means outer, and all this is an order for you to multiply in. I means inner, and then L means last. This is something you should have gotten to in your Algebra 1 class, FOIL. If not, we will have plenty practice in here on it. Okay. So 2x squared, when you FOIL it out, 2x times x is 2x squared. Outer terms, 2x times 2 is 4x. Inner terms 3 times x, 4x plus 3x is 7x, and then last terms 3 times 2 is 6. Do the same thing with all four of those values, or all four of those binomials. But again, it's a trial and error. 2x squared plus 8x, 2x squared plus 8x plus 6, both of those are the same, and 2x squared plus 13x plus 6. This is the one you're trying to get back to. 2x squared plus 13x plus 6. This is the only one by trial and error that works. 2x plus 1 times x plus 6. Therefore, the correct factorization is 2x plus 1 times x plus 6. Again, with these, anytime we have a value of a that's not 1, and again, that's what we mean by the value of a. Anytime it's not 1, anytime there's a shown coefficient, it will not be a difficult problem. What I mean by that is this problem here. Take about 30 seconds and see if you can factor this one out. Notice how small the numbers are. Notice how simple the factors are. So you're going to have to do a little trial and error, but not very much. Okay, let's take a look at this one before we run too long. Notice there's not very many factors of A's value. A's value, you only have two sets of factors, 1 and 4, and 2 and 2. Your C value, notice you only have one set of factors, 1 and 3. So you have to use it, and this is where I was telling you about, this is where it's not very difficult. Since you only have one set of numbers, you have to use that as the other set. So when you make your two sets of parentheses, instead of writing y times y right away like we did a minute ago, we're going to have something times y times something times y. So leave yourself a little bit of a space there. And then plug in these numbers 1 and 3. Again, just like earlier, this one tells you that the signs are opposite, and this one tells you that the larger one is negative. So negative 3 and positive 1. So now all you have to do is make it match the other part. You know that your B value has to be 4. So in order for you to create 4, or it has to be negative 4, I should say. In order for you to create negative 4, you need to make y's value be negative 4. So right here, it's going to be 1 times 4 or 2 times 2. The only numbers that work when you plug it in, and this is the trial and error part right here. If you plug in, and I'm going to write it separate over here just to show you how it doesn't work. Y plus 1 times y minus 3. If you plug in 4 and 1, any combination of 4 and 1, when you FOIL this out, you're going to get negative 12. That doesn't work. So right away, you're not going to be able to use it with negative 12. If you switch the numbers and make that one 1 and that one 4, then you're going to get 3y or negative 3y plus 4y. That's going to give you a positive 1y. That's not what you're trying to get. You're trying to get to 4. So again, only trial and error will get you through this. 2y and 2y are the only factors that work. So 2y plus 1, when you FOIL this out, first terms, 2y times 2y is 4y. Outer terms, 2 times negative 3 is going to be negative 6y. Inner terms, 1 times 2y is plus 2y. And last terms, 1 times 3 is minus 3. So when you put these two together right here, you get negative 4y. Notice you get back to the terms that you were trying to get, 4y squared minus 4y minus 3. That was the trinomial originally. Again, we won't have plenty like that. That's really difficult for a lot of people. But we'll have just a couple just to kind of keep you up on it. Okay, these are two different kinds of special types. The difference of two squares. So here's the example. X squared. X squared means x times x. Difference means it's subtracting. And then 3 is a perfect square as well. Remember, your perfect squares are 1 times 1, 2 times 2, 3 times 3. These are your perfect squares. 4 times 4. Those are the numbers you have to be familiar with. You can keep going and going. 9 is a perfect square. So anytime it's the difference, you put it as x plus whatever this is, the square root of, x plus 3 times x minus 3. 1 plus, 1 minus. That's the difference of two squares. That makes more sense when you work with that. Okay? A perfect square trinomial is also very easy. All you have to do is look at the first term and the last term. So look at A and look at C. Is A perfect square and is C a perfect square? Yes, it is. X squared means x times x. And 36, when you take the square root of that, you get 6. So you simply put it as x and 6, and then you look at the term, you look at the sign that is in front of B. It says plus 12, so that's what goes in between, x plus 6 squared. So that's a perfect square trinomial with it being plus, and this is one with it being minus. The same thing. This is a perfect square, so x times x. And this is a perfect square, 16, which is 4. This right here, this sign is minus. That's what goes in the middle, very simple. X minus 4 squared. And again, these are just perfect squares and differences of two perfect squares. This will make it way faster to do a lot of these things. Here's factoring special patterns. Factor the quadratic expression. Two perfect squares. 9x squared is the same thing as 3x squared, the difference of two perfect squares. So 3x squared plus 4 and 3x squared minus 4, because this is a perfect square 3 and this is a perfect square x. This is a perfect square 4. So that's why it says 3x plus 4 times 3x minus 4. Just talking about the square root of these numbers. If you need to draw in that symbol to where you can see it, the square root of it. That means what times itself gives you that number. Here's a perfect square trinomial. The easiest way for people to do this is to say, okay, is this a perfect square 16? Yes, it is. 4. Is y squared a perfect square? Y, yes, it is. Is this one a perfect square 25? Yes, it is. 5. So you have 4y and you have 5. This sign right here tells you what goes in the middle of them, plus. So 4y plus 5 squared. And then the same thing with this one. Is this one a perfect square? 64x squared. Yes, 8 times 8 gives you 64. X times x gives you x squared, so 8x. Is this one a perfect square? 4. Yes, it is. 2. So what sign goes in the middle of them? Minus. 8x minus 2 squared. And again, this is just showing you a different method than the one I'm showing you on the side, which seems to be quicker and easier for most people. But if what I'm writing on the side is confusing to you, just follow the steps that are listed. Okay? Factor those three out. Take about 1 minute. All of them are special circumstances, so look at the example that's right above it. Okay, let's look at this way you don't get too stuck on it. This first one is the difference of two perfect squares. Is 16 a perfect square? Yes. 4 times 4 gives you 16. Is y squared a perfect square? Yes. Y times y gives you y squared. And is 225 a perfect square? Yes. 15 times 15 is a perfect square. So it's the difference of two perfect squares. That means minus. So you simply write it as 4y plus 15 times 4y minus 15. That's the difference of two perfect squares factored out. For this, and that's all you do with it, yeah. For this next one, this is a perfect trinomial. 1, 2, 3 terms up there. Again, perfect square 4 is 2. Perfect square z squared is z. Perfect square 9 is 3. This tells you in the middle of them you put minus, and it's squared. So 2z minus 3 squared. And same thing with this other one. Perfect square 36 is 6 times 6. Perfect square w squared is w. Perfect square 25 is 5. 6w and 5, this tells you plus in the middle. 6w plus 5 squared. If you went ahead and took these and FOILed them back out, though, you'll see you'll get that b value. Like 6w plus 5 squared means 6w plus 5 times 6w plus 5. That's 36w squared. That's the first thing. 6w plus 5 is 30. It's 60w. I can't talk. 6w plus 5 is 30w, and 5 plus 6w is another 30w. 30w and 30w gives you 60w. And then the two last terms, 5 times 5, gets you back to plus 25. So if you FOIL it out, you'll see that it does come back to it. Okay, factor in monomials first. In example number 4, it says 12x squared minus 3 equals 3 times 4x squared minus 1. Okay, what you're trying to do is you're trying to pull out what they have in common. They have both of these numbers right here, 12 and 3, have the number 3 in common. So you take 3 and you open up a set of parentheses and you ask yourself, what do I have to multiply 3 by to get 12x squared? You multiply it by 4x squared. And what do I have to multiply 3 by to get negative 3? You multiply it by negative 1. So at that point, you have 3, and then you have times the difference of two perfect squares, just like a second ago. So that's why it becomes 3 times 4 is a perfect square, 2. X squared is a perfect square, x. Plus 1 is a perfect square, and x squared minus 1. So that's why it says 3 times 2x minus 1 times 2x plus 1. We're going to do the same thing with b. The term they have in common is 3. Goes into both 3, 9, and 6. So when you take 3 out right here, 3 times u squared is 3u squared. 3 times negative 3u is negative 9u. And 3 times 2 is 6. And then you could factor out this right here. And some of this stuff takes a little while. But then you could factor out u squared minus 3u plus 2 as the two factors of 2, which are u and 2 and 1. It has to be 2 and 1. This tells you they're the same sign. This tells you they're both negative. So minus 2, minus 1. The next one has the number 7 in common. 7. Actually, they both have 7, and they both have a v. So not just 7, but 7v. 7v times v is 7v squared, and 7v times negative 6. Notice you don't have to factor out that binomial v minus 6. That's it. 7v times v minus 6. And then the last one has the number 2 in common. You pull the number 2 out, and then 2 times x squared gives you 2x squared. 2 times 4x gives you 4x. I'm sorry, 8x. And 2 times 1 gives you 2x. Then simplify that one. 2 times x times x and 1 times 1. We're not going to simplify that one out just now because we actually have to. This is going to be another lesson. Notice we don't take it to the next step because when you use the factors of 1, they don't get you to b's value. That's something where we're going to have to do something called completing the square. I'll show you all that when we get to it. Completing the square. Okay, take about a minute and factor out what they have in common for these four. Okay, for the first one, what do all three of the trinomial terms have in common? They have the number 2 in common. So you have 2 times 7x squared gives you 14x squared. 2 times x gives you 2x. And 2 times negative 6 gives you negative 12. And we're gonna stop at that point. We won't even bring it down to the next term. Just to make it a little bit quicker for this video right here. You're taking out the factors they share in common. Like for this next one, they both have 3 and they both have a v. So you want to take out 3v. 3v times v gives you 3v squared. And 3v times negative 6 gives you negative 18v. So 3v times v minus 6. For the next one, they have the number 3 in common again. 3 times 4x squared plus 3 times x is 3x plus 3 times 1. And again, from there, since we have a different a value, we could trial and error that out. Even though there's only one factor of 1, we can get to it, but this is as far as we want to go for right now. And then the last one, 4u squared minus 36, they both have the number 4 in common. So 4 times u squared is 4u squared. And 4 times negative 9. We will take this one out further, though, since we have the difference of 2 perfect squares right here. So it'll be 4 times u plus what? What's 3 times u minus 3. So 4 times u plus 3 times u minus 3. With this in a minute. Okay, for this one right here, notice we have numbers that go into all 3 of these numbers. The number 6 goes into all 3 of them. So 6 times c squared minus 8c minus 9. That's something we could factor out. And since the coefficient of c squared is 1, it's actually not rough or it's not difficult for us. You just simply make it 6 times c times c, and then we need the factors of 9. Factors of 9 are 1 and 9 and 3 and 3. The only pair of those that get you to the number 8 is 1 and 9. So you have to use the numbers 1 and 9. This tells you that the signs are different. This tells you the larger number is negative. So that one's negative, this one's positive. Number 2 is the difference of 2 perfect squares. The square root of 81 is 9. The square root of x squared is x. And the square root of 1 is 1. 9x plus 1 times 9x minus 1. The difference of 2 perfect squares. (49h squared plus 42h plus 9). Okay, so we know that the number 9 doesn't go into all of them. Maybe the number 3 does. So if you check 3 going into Um, 49, that one doesn't go into it either. Okay, I see. Come on. But one good thing about this is a what's called a perfect trinomial. This one has a perfect square right there. The square root of 49 is 7. The square root of h squared is h. And the square root of 9 is 3. So 7h and 3, that's going to be squared. This right here tells you that in the middle of them, the sign in front of b tells you that it's going to be plus. This is one of those special cases. 7h plus 3 squared. Number 14, you can take out the number 4. So take out 4. 4 times 4x squared is 16x squared. And 4 times negative 1 is negative 4. We already had the difference of two perfect squares, but this makes it even better. So 4 times 2x plus 1 times 2x minus 1. The zero product property says that when a times b equals 0, then one of the numbers has to be 0. Okay, this is where it actually starts to get easy for most people. Once something's factored out, like 4x squared plus 13x plus 11 equals negative 3x minus 5, what you have to do is you have to move everything over to one side to where it says equals 0. So you know how to move over minus 3x. You add 3x. If you add 3x there, you have to add it to the like term here, and you get 16x. If you have minus 5, you add 5, you add it to the like term here, and you get plus 16. Notice on this line, it now says equals 0. So written in standard form, ax squared plus bx plus c equals 0. From there, you take out what they have in common. They all have a 4 in common. So when you factor out the 4, you get 4 times x squared plus 4x plus 4. Notice how much smaller the numbers are at this point. So now what you did was you canceled out that 4 and you made things that are much smaller. When you factor this out, this doesn't even count anymore. When you factor this out, it's x times x. And then you need the factors of c, which is 4. Remember, you only have two factors of c. 1 and 4 and 2 and 2, or I should say two pairs. So the only numbers you can use are 2 and 2 to get to b's value. This sign tells you that the numbers are the same sign. This tells you they're both plus. So x plus 2 times x plus 2 equals 0. So right there, all this says is what I just wrote. X plus 2 times x plus 2 is the same thing as x plus 2 squared. Yeah, you can put a square behind it. I just wrote them as two separate ones because I factored it out that way. So right here, if it equals 0, x, you simply write it as two separate equations. It happens to both be the same this time. So, but you write it as two separate equations. X plus 2 equals 0. And then if that was a different number, you'd write it as x plus 2 equals 0. When you subtract 2 on both sides, you get x's value is negative 2. We're going to look at another one in a second where you'll come up with two separate numbers right there. And you'll find out what the 0 values are. And this is actually called solving the quadratic equation. Okay, take a minute and do these two real quick. Remember the difference. Remember perfect trinomials for these. Make them say equal to 0.